So, you're building with large language models. You've definitely seen the magic they can do. But I bet you've also hit that wall, right? Trying to get consistent, high-quality results. Well, in this explainer, we're going to break down exactly how you can master model optimization on the OpenAI platform. And really, this is the central question for any developer in this space. I mean, these models are non-deterministic. That's just their nature. Their behavior can shift and change. So how in the world are we supposed to build reliable, production-grade applications on a foundation that's, designed to be a little bit unpredictable? That's the puzzle we're here to solve today. All right, here's our game plan. First, we'll really define the optimization challenge itself. Then, we're going to walk through the three main pillars: evals, prompt engineering, and fine-tuning. And then we'll tie them all together into this really powerful continuous process called the optimization flywheel. Okay, first up, the challenge. Let's really dig into why these incredibly smart models need our constant attention in the first place. Here's the most critical thing for developers to get their heads around. A prompt that works perfectly for you today might not work the same way tomorrow after a model update. And listen, that's not a bug. It's just a fundamental feature of how these models evolve. It means the old set it and forget it approach, it just doesn't fly here. We have to build our systems for continuous measurement and constant tuning. And that's exactly where model optimization comes into play. You got to think of it less as a single technique and more as a whole philosophy. It's this continuous cycle where evals, prompting, and fine-tuning all work together, feeding off each other to systematically get you better and better results. So let's dive into our first pillar, evals. Seriously, think of evals as your compass. You can't navigate without one, right? Well, you can't improve what you can't measure, and evals are how you measure. So what are evals? Well, they're basically a structured way to test your model's output. They let you create a performance baseline, a kind of ground truth that tells you objectively, how good is my model right now, before you start messing with prompts or fine-tuning. It sounds simple, but it's everything. Flying blind is not a strategy. Without a solid measurement system in place, any change you make to a prompt is just a shot in the dark. Evals are what turn those guesses into data-driven, repeatable improvements. Now, the workflow here might actually flip how you think you should approach this. It's a lot like test-driven development in traditional software. The best practice is to write your evals first. You define what success looks like, you create the tests to measure it, and then you start engineering your prompts to pass those tests. Okay, so we've got our measurement system in place. Now we can move on to the second pillar, prompt engineering. This is by far the fastest and most direct way you can start guiding your model towards those better results you're after. At its heart, prompt engineering is just about having a really clear conversation with the AI. You're giving it all the pieces it needs to succeed: the background info, a super clear set of instructions, and a well-defined goal for what a great output actually looks like. There are three core practices to always keep in mind. First, give it context. Any relevant info the model couldn't possibly know on its own, you gotta provide it. Second, give it clear instructions. Be super explicit about the task and the format you want back. And third, give it examples. Honestly, the best way to tell a model what you want is often just to show it. We call that technique few-shot learning. So prompt engineering is always your first tool. It's fast, it's flexible, and it is incredibly powerful. But it does have limits. What happens when you need to give the model more context than you can fit in a single prompt? Or when you need to really optimize for cost and speed at a massive scale? Well, for that, we need our third pillar. And that brings us to pillar number 3, fine-tuning. This is where we go beyond just instructing a general model, and we actually create a brand new specialist version of it that's trained for your specific task. So what is it? Fine-tuning is when you take a powerful base model like GPT-4, and then you train it even further on your own custom data set of examples. What you get out the other side is a new custom model that's an expert in exactly what you need it to do. So why even bother with fine-tuning? Well, the advantages, especially at scale, are huge. You can teach the model using way more examples than a prompt could ever hold. This means you can use shorter prompts, which saves you money on tokens and reduces latency on your API calls. It's also a more secure way to train on sensitive data. And get this, it can even let you use a smaller, cheaper model to get expert-level performance on one specific task. Now, there are a few key ways to fine-tune. The most common is supervised fine-tuning, or SFT, where you just show the model a bunch of good examples. Then there's direct preference optimization, or DPO, which is really clever. You show the model both a good response and a bad one, and that teaches it to understand your preferences. And for really complex stuff, there's reinforcement fine-tuning, or RFT, which uses expert feedback to grade the model's reasoning process. So, we have our 3 pillars. We measure with evals, we guide with prompts, and we specialize with fine-tuning. Now, let's put it all together into this single process that makes this whole system sing, the flywheel. This right here is the optimization flywheel. You start by writing evals to set your baseline. Then, you engineer your prompt. If you need to, you fine-tune a model. And then, and this is the absolute key, you run your evals again to measure the impact of your changes. Based on those results, you tweak your prompts or your data, and you just repeat the loop. And it's so important to remember, this is not a linear process with a finish line. It's not a one-and-done fix. It's a continuous cycle. Every single time you run this loop, you get new feedback that makes your prompts sharper and your fine-tuning data better. Ultimately, when you embrace this cycle, you create that powerful flywheel of feedback. That flywheel is the engine that transforms that unpredictable AI behavior into the consistent, high-quality results that real-world applications absolutely demand. So that leaves us with one final question for you to think about with your own projects. Is your model just working? Or is it truly optimized? The difference is building a system for excellence. And now you have the roadmap to do it.